Welcome back. This is Mr. Greenstein's Geometry, and we are in Chapter 8. We're going to be looking at Section 8.3, Proving Triangles are Similar by Side, 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 and Side, Angle, Side. So let's first take a look at the theorem, side by side, or side, side, side similarity. You can see that with this is a little bit different. Has a little tilde there, and that differentiates it from the side, side, side congruency that we were doing before. This says that if corresponding side lengths of two triangles are proportional, then the triangles are similar. So we can say here that the corresponding sides, AB and RS, if we take that ratio, that's the same thing as the ratio of taking from BC to ST or CA to TR. And if all of these are the same, in other words, that they have the same ratio, then we know that the two triangles are similar. We don't even have to know anything about the angles. It just turns out that once two triangles are similar, then the angles are going to be congruent, because that's the definition of similarity. So which pairs of triangles are similar? What I'd like to do is first take a look at this triangle here and look at the longest side. So I have 16 here. The longest side of the second triangle is 12, and then 16 here. Oh, well, that's kind of nice. Let's just compare the first and the last one there. This 16 corresponds with that 16. Then let's take the shortest side. Shortest side is 8 here and 8 here. Oh, well, that's good. We already have two sides that correspond, and the ratio is 1 to 1. So 16 times 1 gets you 16. The same thing with 8 to 8. But this is where it falls down. The middle length side, 12 and 10, don't match up. They don't go to 1 to 1. So these two triangles are not similar. Let's take a look at this triangle and this triangle. So if we go from 16 to 12, 16 to 12 means that we're going to have 12 sixteenths, which is the same thing as taking 3/4. So let's see if the other sides are also 3/4. Let's take the shortest side, 8 to 6. Well, 8 to 6 is 3/4 because it's 6 over 8. If we take the side, let's see, so we have 16 twelfths. 16 divided by 12, or 12 divided by 16, we already took that one. So let's take the middle sides. The middle side is 9 and 12, and if I take those two, I also have 3/4. So in each one of these cases, I have a similarity ratio, or a ratio of 3/4. Therefore, the triangles are similar. What values of x make these triangles similar? So if we want to make them similar, then we have to find corresponding sides and make their proportions the same. Well, what I would like to do is I would like to say that ABC is similar to DEF. Therefore, side AB is going to be similar to DE. And if you notice, 4 to 12 is a multiple of 3. So I multiply 4 times 3 to get 12. So I'm going to do the same thing with x minus 1 to get 18. So I'm going to say 3 times the quantity x minus 1, and that's going to give me 18. And if we work that one out, then we work out that x is equal to 7. I believe, yes, 7. So x is going to be 7. And if we plug that into this last one here, 8 goes to 3x plus 1, we're going to say that 3 times 8 is equal to this quantity here. And that's going to say, we're going to say 3 times 8 is equal to 3 times x plus 1. And it turns out that x is also 7 on that side. So everything works out just perfectly if x equals 7. Now let's talk about side angle side similarity. Once again, we're using that little tilde at the end of side angle side, so it's not the congruence theorem. And this is also talking about triangles. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. So we have a congruent angle, and we have proportional sides that are on either side. So if we look at this, we're essentially saying that if we have an angle, so here's our angle, x and m, they're congruent, and then I have proportional sides, so zx to pm, and the same thing as xy to mn, then the two triangles are similar. Let's use this side angle side similarity when we have a lean-to shelter. If we look at this, are the left and right ends similar? Well, let's just take a look. We have 53 degrees here and 53 degrees here. Well, there's our angle that we're going to be using, and we're going to look at the sides that include that angle. I have 9 feet compares to 6 feet. Well, going from 6 to 9 is essentially 3 over 2. So that means we're going to have to look at the other side and see if that's 3 over 2. If we go from 10 to 15, is that similar? And it is. It is 3 over 2 is the proportionality. Therefore, the left and right ends are similar. Now let's verify these polygons are similar. And then let's name the theorem. We have 3 different similarity theorems that we could use. Here I have 3 sides, and I have 3 sides. So it looks like it's going to be side, side, side similarity if they are similar. Let's compare. If I look at this, the longest side here is 6, and this is 3.6, and you can work out the ratio on that. The next, or the smallest side length is 2.1 and 3, and I'm going to leave it to you to come up with whether those ratios are the same. So we're going to be looking at 3.6 compared to 6. Is that equal to the same thing as 2.1 compares to 3? And then you can decide whether or not, oh, I'm sorry, that's not right. It's actually the shortest side is going to be 1.8 compared to 3. So we're going to compare 1.8 to 3 and see if those two things come out being the same. And then on the second one, on B, here we have an angle, and we have an angle, they're congruent. Therefore, we're going to be looking at side angle side. So we have side of 2, here's 1, and we can see that is a 1/2 going from 2 to 1. It's also, the other side is 5.8 to 2.9. Well, that's 1/2. So this one, we can see really quickly, this one is going to be similar. The first one, I'll leave that to you. And we'll discuss the rest of these in the next day of class.